and good morning. Welcome by the New Scientific News. Today we're going to talk about a hot topic, microplastics, a global threat to the environment all over the world.
Today we're going to find out if microplastics have an influence on the filter capacity of mussels. Let's hear from our researchers, live on Texel.
Our GRQ is, do microplastics affect the filter capacity of mussels?
Our hypothesis. We think that the microplastics will affect the filter capacity of the mussels in a negative way, as we think that the microplastics will become stuck in the mussel, therefore other particles will not be able to pass through as easily and then cause the mussel to not filter as well.
Before we can start the experiment, it is very important to put on some sunscreen. Then we set up the experiment. To do this, we needed to collect water from the ocean and distribute this over our 12 tanks. The next day we collected the mussels and added them to the tank. Afterwards, we started our experiment. The best way to measure the filtration capacity is using algae and a photospectrometer. We set up the experiment with 12 small tubs of 5 liters with 5 mussels in each tub, adding different amounts of microplastics in different tubs, followed by the algae and mixing the water well afterwards with a spoon. Mussels consume algae via filtration of water. Using this information, it is possible to calculate the filtration rate of the mussels by calculating the difference in the number of algae in the water over time. Because the mussels are filtering away the algae, this is done by using a photospectrometer. A photospectrometer measures the amount of light of a certain wavelength. In this case, the wavelength of green light. You can see the greenish color in the test tube filled with algae. The wavelength we used was 646.
Here you can clearly see how we put the mussels into a bag. Later this bag is put into the freezer because the mussels who have microplastics in them cannot be released back into the wild. So we put them to death humanely.
We added the results of our experiment into a graph. This graph shows the algae concentration against the time of our experiment. The box plot shows the average decrease of algae concentration per treatment added. As you can see, all of the different treatments of the microplastics added have roughly the same box plot. Following the results measured with the photospectrometer, we can conclude that adding different amounts of microplastics to the water did not influence the filtration capacity of the mussels used in the experiment. We conclude this based on the statistical analysis done on the measurement results. The microplastic concentration of our water is still a lot higher than the concentration of microplastics in the Wadden Sea. Following this, we can conclude that the concentration of microplastics in the Wadden Sea does not affect the filter capacity of the mussels, which means the water in the Wadden Sea is still being filtered as it always has been, ensuring clean water. We do not know though how much influence the microplastics have on the mussels overall, so that should be looked into. We recommend a follow-up study. In this follow-up study, the plastic concentration would be way higher and there would be multiple different sizes of microplastics.
So, we're back to the studio. Are there things that went wrong?
And are there things you would do differently next time?
We're now live from the mussel bank on Texel. One of the things that went wrong in our experiment is that there was a crack in one of our containers. Due to this, some of the water was lost, and which ended up messing with the particle distribution as we had to add new water.
And some of the microplastics also got stuck behind the tape in the container, which means that the amount of microplastics that are distributed in the water are not the same as we put in the water.
Now the things that we would do differently in our experiment if we were to do it again, we would try and find microplastics that are not green. We added green microplastics, but these also reflect the same light as the photospectrometer. So if there was still some microplastics floating around in the water, these will have had influence on the results.
And there was also the mixing of the water. We found that after some time the microplastics and algae would settle in the water of the tubs, making the filtration of the mussels harder. So for any future experiments, it is wise to bring small pumps to continuously mix the water.
The microplastics were also added in a solution and not in weight. This meant that we could, in the end, not determine exactly how many microplastics were exactly added.
The mussels and water already had some sediment, which is different for each tank, messing with the photospectrometer results.